Okay, today I'm going to be going over how to install any software needed, the drivers, and then do a complete project in Vivado, then how to download it to the FPGA board. So the first thing we'll need to do is to go to Pigeon's website with FPGAs, then go to the Basys 3. Once you are there, just scroll all the way down and you need to download the file here, the XDC file. That's basically the constraints file for Vivado. You see we already have it downloaded. The next thing you'll need to do is to download the drivers for the Basys 3 board. Simply go to Software. Click here, and you'll only need the system. You won't need the actual utility or SDK. So we'll install those. Well, apparently I already have them installed here, but so we're good there. So if you do that, you can start Vivado. Create a new project. Just need this project example. RTL project. We don't have any sources to add at this time. Change the stuff to HDL. I have an existing IP constraints file, so simply extract here. You can do your constraints file and add file. Here, it should be that. The easiest way I found to do this is just to go through this rather than try to find a long list. And that is our part right there. So, basically what I'll be doing is, you'll have the, sorry about this, I need to change the microphone position a little. Basically you'll have 4 switches, will be the inputs, and then you will have two outputs, one output being an LED and the other output will actually be an LED, but one LED will be if the output is prime and the other one will be if output is even or odd. So first thing we need to do is to add source, add a create design source, then create file. So this will be our top level BCL file, so we'll just name it top. So we're good to go. Finish. And for this we'll have switch, which is an M, and it'll be a bus, and it'll be 3 times 0. So I'm going to be using 4 switches. We'll have LED, which will be an out, and it'll be a bus, and it'll be 1 down to 0. 1 for being if it's prime, and 1 being for if it's even or odd. So, we're good to go. So, we currently have top. Now, I'm going to create another one. And this will be prime. Okay, finish. We'll have our input one, which will be I don't know what to call it. So we'll just call it 0 for now. We'll be creating 0. Just call this is prime. And we'll be out. Let me check something. Okay, so input isn't a HDL keyword. You not get that sometimes. So, what we'll do is also create the last source we need. So, design source. Create file. Name this one even time. So we'll call this input. And 0 and let me just have this. Actually, I think I'll change it where one LED will light up if it's even, another LED will light up if it's odd, so we'll just call this odd. Output. And even. Okay, so since we're going to have 3 outputs versus 2, we just go to the top and change it from 1 down to 0 to 2 down to 0. So, we have our 3 VHDL files, one being the top level, and then one being even odd, one being prime. So, since we have our inputs, which is just switch and output, which will be LED, so we can go to the constraints file. So we know we'll need to uncomment the lines corresponding to switch 0 down to 3. And also, since we're using 3 LEDs, likewise, for that with the LEDs. Oops. Whoa. One too many. There we go. So now, we have it where our LED signal will be tied to these pins, which obviously, since this is the constraints file for the board, safely assume that it actually goes to those. So, let's go to prime. So, you can do this multiple ways. You can do it like when else, you can do a if else, you can do a case. Personally, I think it would be easier just to do a when else, so that's what I'll be doing here. But likewise, you could do it with in control statement you want to use. So, basically what I'm going to be doing is this. Basically, one when and prime. So, you can say input is equal to 0. Oops. Else. And you obviously do not need a comma after that else. Let's do this. So this will be a, I could type, so this will be one. So we'll need 1, 4, 2, 3. Vivado not being logged in correctly. So 2 is a prime number, 3 is 1. So we need 1, 4, 5. Seven. And 1 for, let's see, 9 isn't a prime number, so we need for 11, 13. Okay. Now, we just need to go through and change these so they are binary actually represents the number. So for these, the easiest way to think about it is 8 plus 2 plus 1 is 11. Likewise, 8 plus 4 plus 1 is 13. Now, one thing I've noticed is that a lot of people, even if you're doing all of the possible input combinations for one else, you always need to have one where it's just else, because otherwise the VHDL synthesizer will think, oh, even if he's specifying all the cases and there's no else, so he obviously must want a latch. And that is probably, what I'm guessing, is not what you want. If you don't want to infer a latch, you always need to have some sort of else, or a when else with a if statement, or an when others with a case statement. Otherwise, for combinational logic, you will be inferring a latch, which I do not think is what you'll be wanting to do. Maybe it is, maybe it's not. I don't know. But I'm just throwing it out there. So we have all of our prime numbers: 0, 1, 2, 3, 5, 7, 11, and 13. So save that. And we have 2 critical warnings. Oops. Sorry. Here, see this next error where save that. We're all good. So, since we have prime down, let's go to an odd. So we have 2 outputs, even and odd. So since we're assuming we're going to be dealing with unsigned numbers, it makes it relatively easy. So odd is 0 when input 0 is equal to 1. Else 0. So basically, when the least significant is 1, the output is 1, else it is 0. This could actually be done this also. It was basically the same thing. So for even, we could do the when else statement, or we could simply do that. So it's really easy to do the logic to this. So we have our even and odd and our prime. Now we won't implement those or to use them actually in talk now. So to instantiate, not instantiate, to declare a component, it's component. So we'll do prime port prime HDL. Copy that. Paste it. And save. We're all good to go. So now we'll do even and odd. Declare that one so we can use it. Copy and paste it. Even and odd, we have input, which is the same. We'll have even. And we also have, oops, right here. On, use out, and standard logic. Type that on be nice. Anyway, so we have declared both of our components we're going to use. We have prime and even and odd. So now we need to basically instantiate them. So first you need a unique name. So for ours it's prime instantiation 0, or instance, or whatever they're called. So we have that, and it will be prime port map. Then we have our input, which is the input into prime. Will be tied to switch. We don't have to specify any of the how many bits or indices of the vector or bus. Simply because they're both 3 down to 0. So that's all you have to do. You don't have to specify 3 down to 0 for anything. Since they're both 3 down to 0, we can just simply tie input to switch. Then we have is prime. I'm going to tie that to LED. So we've instantiated prime. The instance name is prime instance 1, instantiation 1. We have our input tied to switch, and is prime tied to LED 1. So we should do the same thing. Even odd, not exact same thing, but so we have the instantiation name is even odd instantiation 1. Even odd is the entity we want to instantiate. We have port map. We have our input is also tied to switches. We have even, which we will output to 21, odd, which will go to LED 2. So, we save that. I'm surprised I don't have any errors, but good to go. So, as we have this, we might as well create a simple test bench for it. So, add sources, create orders, add or create simulation sources, create file, top, test bench. Okay, finished. Since this is a test bench file, obviously we don't need any inputs or output ports. Miss silence. So, over here. Likewise, how we had to declare components, we need to declare top. So, component top. Port. So we'll have our input, which is switch, which will just be efficient. Go to top. Quick save, good to go. And for test benches, generally what I find is it's easiest just to create signals. Silly mistakes, that might be nice. So you simply declare a signal switch, which is standard logic vector 0. Microprice with LED, although it is 2 down 0. So, the whole test bench thing isn't really needed for what you guys are doing, but I figure I'd just go through simply the process of how I create one. And another thing we'll probably need is signal counter, which we'll just do sine 3 down to 0. Initial value will be 0. Okay, so we'll do under test, top, map, which within the switch of the component is tied to the switch signal we have, and then LED of the component is tied to the LED signal in the test bench. So we have our instantiation. So since we have basically a combinational circuit, we have 4 inputs. So the easiest thing would be to simply go over those inputs in order, which would be 0, 1, 2, 3, 4, etc. like that. So that's why I declared the counter signal. So you could simply assign switch to counter, but obviously you need something to actually drive counter. So create some process. You wait 10 nanoseconds, Or is it wait for? I forget. We'll find out soon enough. Simply counter to counter. Oops. +1 in the process. Basically, for simulations, if you want to do a counter, that's how you do it. In actual hardware circuits, that is not how you do it. So this is just a simulation-only counter, just FYI. And obviously, error. That's what I thought. It's week 4. And we're good to go. So, look over here. Top test bench has one instantiation of top. And that top has 2 instantiations, one being prime and one being even odd. Go to simulation settings. It is top test bench, so we're good to go. And behavioral simulation. Okay, this is a common error that doesn't necessarily mean anything. The error itself does, but if you go over to the TickLe console, you'll be able to actually see what's actually going wrong. So, error near counter current. So same here. Error around in here. Expected type. Oh. Basically, VHDL is a strongly typed language. So you have to convert an unsigned vector to a standard logic vector before you can assign it. So, oops, what? Thank you, Windows. My antivirus software sometimes. Okay, so let's just do this real quick. Let's move this over. Obviously, that is more than we need to see, so let's just zoom into that. Okay, let's use islands for So, the easiest thing would be to go to the switch and change it to SO, X, whatever. So we know that if it's even, LED 1 will light up. If it's odd, LED 2 will light up. So from here, we have 0, it is prime and it is 1. It is prime and it is odd. 2, likewise, it is prime and even. 3, it's prime and odd. 4 is even. 5 is odd and prime. 6 is even. 7 is odd and prime. 8 is even. 9 is even. 10 is even, etc. So, you can go through the last cases just to make sure it's right, and it looks to be right. So, everything is working correctly. Let me just see if I can do this real quick. There we go. Likewise, all these check out like they should be. So, it's working correctly. Close the simulation, discard, Then we can go to generic bit stream. So, I'm not sure how long this will take, but in the meantime, let me set up the FPGA board real quick. Setting up the FPGA board is rather simple. What you do is you take a USB cable and you literally just plug it into the USB port. You set up the video camera real quick and record all this. Okay, so here, what you can do is you just hit cancel. You run that. We want to turn on your FPGA. The default bitstream or whatever gets loaded on first is just a test. You can do things with it if you want. Those light up. So, in Vivado, what you'll want to do is to go to Open Hardware Manager, Open Target, New Target, why are you not working today? Okay, there we go. Do that. Next. Finish. So then you program device. Program the XC7132T_0. The default bitstream will be the one you want. Program it. And then you can see that we have our bitstream here, because 0 is both prime and even. We have 1, which is prime and odd, 2, which is prime and even, 3 is prime and odd, 4, which is just even, 5 is prime and odd, 6 is just even, and 7 is prime and odd. 8 9, 10, etc. So, you can see that the circuit works correctly. So, that is pretty much all there is. Hopefully this demonstration has been helpful. So, anyway, thank you for watching.